So today I will give you a talk about surface technology. That how can we create an armor, or should we maybe create some makeup for materials? Surface technology, you may wonder what this word means. By this word, we mean the design and the modification of the surface of a material. And that's why I like to call it actually surface engineering, because we have to engineer this modification considering both the surface as well as the substrate as an integrated system to give those performances and to reach those performances that we need, that which neither of them are capable by their own. So surface engineering, you will see today, impacts on almost all industrial sector and almost all of your everyday life as well. And therefore, I personally think it's of most importance to go into more understanding of it and do research to develop it further. The principle behind surface technology based on 3 different concepts. How can we change the surface of material? Well, first of all, we can simply add extra material, add different material on the bulk. Otherwise, we can chemically or physically change the surface layer of the material that we are treating. Or we can even consider not to change the chemistry and the property of the material on the surface, but to change the topography and the profile of the surface. And to understand it better, let's consider and look around in nature. If you look around yourself, even in this room, you will see that everything has a modified surface. For example, if you look at the tree, then you look at the surface of a tree, then you see that there is a bark on it, or a nut. It has a shell around. Or animals as well create a different surface. And why is that? They need protection, and therefore they build up an armor around themselves. Or we can see also beautiful color, odor, flavors. And why is that? That is to attract the rest of the world to them. There are also very smart considerations how the surface behave. Let's consider a tomato trees. Are the trees red from the beginning? No, they are not. They are green, and the surface color is changing from green to red to give you a signal and to attract you to them. Now we're ready. You can pick them up. Animals use the color change in a very smart approach. They can mime the color around them to get hidden, or they can treat their skin to, for example, like this little duck, not to get wet when they want to swim. The feather of this little one, for example, has a special coating that makes them hydrophobic, so they cannot get wet when they are soaked in water. So, surface technology in nature is adding a smart functionality as well. So it's not just an armor, it's not just a makeup, it's not just a combination of those, it's something more. So, why is surface so special? First of all, from a chemical point of view, from a physical point of view, the chemical, the atoms, the chemistry and the properties and the energy of those atoms that sit on the last layer of a material are different from the one inside. They will behave different because they have a higher energy. And why do they have a higher energy? Because they are not surrounded by similar atoms. They are facing the external environment. And there is the boundary between the material and everything else. And that is the interface where all interaction will happen, depending on which material is one side and which environment is on the other. So let's take an example that I imagine all of you can relate to. The Liberty Statue in New York. So despite it's just 8 in the morning, I would like you to take your smartphones and go to www.menti.com. So there will be a question for you. To enter the question, you need to use the code 150299. Let me activate it first. Yes? And there you have different options. Which material is the Liberty Statue surface made of? I'll just give you a picture for those that doesn't remember. I hope I can go back and forward maybe to show it to you again. Not really. So someone says copper. We also have bronze, plastic, paint, and wood as option. Let's just wait some minutes now that I see the numbers are increasing. So the vast majority of you think that Statue of Liberty surface is made of a metal, and in specific is made of copper. Some of you consider, well, bronze is a copper alloy, so also these 15% are quite close to the same concept, but some of you think there is a paint on the surface. So if can I have the technical assistance to move to the next slides, because the computer is not going to the next one. I will show you what is happening on the surface. Well, first of all, I would like to say that half of the audience is right. Copper is the surface material of the statue, Liberty statue. Should I maybe ask? Yes, let's do like this. So, despite that, you all know that copper material have a reddish color, right? So why is this green instead? Well, the Liberty statue was installed in 1886, and in this long time, it has had a spontaneous chemical conversion of the surface. And in specific, the copper interacts with the oxygen in the environment to create copper oxide. But actually, copper oxide are brown in color. But by sitting there on the surface, the copper oxide further react with the environment, and specifically with the CO2 present in the air, to develop a double salt copper carbonate in two forms. One is green, and the other is bluish, and their mixture gives this specific color that you see in the surface. Because it is a spontaneous chemical conversion coating, it's like a live surface. It will change and keep changing over the year, depending which ingredients are more present in the environment. It can react even with sulfur, even with chloride, adding new nuances between blue and green and brown to this surface. So this is a nice positive interaction to the environment. But other metals interact not in the similar way, but the result is totally the opposite. If we consider what happens to iron or steel in the same condition, the surface appearance is what we call rust. And it's not as nice to see, and not only not nice, but not protective at all. Imagine that the Statue of Liberty from 1886, more than 100 years, lost only 0.1 millimeter of the thickness of the surface. If we want to do a comparison, a steel exposed to the same atmosphere will lose 0.1, the same thickness, in only 2 years. So you do understand that spontaneous interaction with the world needs somehow to be controlled. But no matter if you want to control them or not, it's really important to understand them in order to predict them, so that we will know what will happen to our manufacturers. We need to control, we need to understand if we want to add protection, if we want to change the surface to add a makeup, if we want to develop smart function, miming what's happening to some natural phenomena. But we should be able to control the spontaneous material-environment interaction to our benefit, and to save costs, but also to make a better use of the planet resources. So let's give you an example after the spontaneous interaction of something that the humankind engineered. The first example I would like to give is the example of an armour. And among many, I choose to show the Golden Gate Bridge in San Francisco. This fabulous infrastructure is made of steel and some part of cast iron as well, and different type of steels. And if you remember what I just said, it will lose thickness in a very fast way. But this infrastructure is there for a long time, and we wish to keep it there even longer. So what should we do? We did modify the surface, giving this nice red color, but it was not because of that. We did painted the steel to protect it, to block this dissolution, this thickness loss, so that the infrastructure could be functional for a long time. Let's take an example of a makeup now. And for that, I chose the City Wine Complex in Spain by the architect Frank Gehry. This is a winery, famous winery in the Rioja region, where there are really good wines. And the architect decided to combine, you see it's quite a rural characteristic area around, so he built this winery out of stone, but he wanted to give a sign of innovation and art to the system. So he added these metal sheets. But that was not enough. So he decided to treat them, and now we will see how, to give this special reflection color, pink, blue, yellowish. And the amazing thing is that this color changed nuances by changing light as well. Why? This is because this material is anodized titanium. And when we anodize titanium, we are growing a little titanium oxide on the surface. The spontaneous titanium oxide has a thickness between 0 and 10 nanometer, and you see that in that scale has no color practically. It has just the metallic color. But if we force a further increase of the thickness, this little tiny layer will interact with light, giving diffraction pattern and giving color, reflecting color, therefore developing different color proportionally to its thickness, only when interacting with light. So different light angle in the morning, midday, or in the evening will give you slight change in the nuances, and engineering the thicknesses on different plates will give you also different colors. But if you think in your everyday, let's set apart those famous examples and think about around you in everyday life. Everything has a coating or a surface treatment, from your BBQ system, from food packaging that you are buying every day, houses, architecture, infrastructure, bridges and roads, technology, interactive screens, transportation, safety issue here come in place that surface technology is taking care of, from train to navy and airplanes. We need an armor around them because we cannot afford any damage there because our safety is in place. Energy system as well. Biomedical material as well. Let's take here a closer look. I give you some different examples of temporary or permanent prostheses, for example. Well, those are metallic material. And you see, for example, the hip replacement parts. Hip replacement parts is something that will substitute part of your joint and your bone if it gets damaged. And this is made of different metals and different materials, but it has an engineered surface for many different reasons. First of all, we want to make it biocompatible. It has to properly interact with the body. It should not harm us. Second, corrosion resistance. Now, we don't care so much about the degradation of the metal, but remember that any degradation product will remain in our body, and this is what we care about now. We do not want to receive in our body any degradation product. And third, the proper interaction with the mechanical load, with the functionality of the piece. And therefore, different parts need different surface topology. Very shiny, some of them, because they need to move. Very porous and rough, some of the other, because they need grip to the bone. Additionally, very often, we even add an extra functionality here with a special coating to promote osteointegration, to promote the fact that the bone can grow and be healthy around this external body. So, what type of properties can we change by surface technology? If we think about armors, we think a little bit about protection, and protection is about chemical degradation, corrosion, mechanical loads, and damages. And then we need hardness. Maybe we need a harder material on the surface. We need definitely wear resistance. If we have some contact, we need to stop it and avoid that the material gets removed. Corrosion resistant, definitely. But maybe we do need thermal conductivity or special optical properties. If we think about some makeup, then the properties we do study and create are gloss, from very shiny to very matte surfaces, colors, as I show you in the example, and again, a little bit corrosion resistant, because corrosion resistant is a degradation mechanism that can ruin the functionality of an object, but can also ruin the appearance of an object as well. And what is most critical in a surface treatment? If it is a coating, the most critical parameter is adhesion. If we add a material onto a bulk, we must assure that this material becomes part of the integrated system and attach to the bulk material strongly. And therefore, we do study the interaction forces between the new material on the surface and the bulk material. And these forces can be created by at many different levels, giving you many different energy between atomic interaction, secondary energy bonding, primary bonding. There are many different types of interaction. Sometimes even simply mechanical anchoring. But we do use surface technology to design those bonding, to design them in terms of number and in terms of type. The second property of main importance is porosity. Now, we gave example about, okay, we have a new material on the surface, but this new material, to be working, needs to act maybe as a barrier between the old material below and the environment. And a barrier is as efficient as much integrity it has. And therefore, porosity formation, porosity distribution is a critical parameter. And in some cases, we should completely avoid it, and then we needed to study the cause, the root of the porosity formation so that we can stop it. But in some other cases, may even be an engineering design of porosity material, because maybe we want to have a sponge-like surface for water absorption. So this is a geometrical parameter that we can control on the surface as well. And what can we do? What can we have on the surface? We can have any type of chemistry. The most common is to have oxide and ceramics. We can have different metals, polymers, or even composites. And we can add this material and modify them if we consider that we want to modify the morphology. We can do polishing to smooth it. We can do pinning or laser treatment. if you want to convert the chemistry, make use of the material that you have, but to transform it slightly, we can do anodizing, like in case of titanium before, passivating, we can do thermal diffusion or ion implantation. And if we want to add material, then we enter the big chapter of coatings. And we have so many different techniques to develop coatings. It's a very complex and diversified field. And how can we get our way through it? Our way through it depends on identifying what you need first, identifying the surface properties that are needed, evaluating the cost involved in these treatments, understand among the different material and the different processes which is the possible and suitable combination, considering the material you are treating, considering its geometry, considering the limitation, and also considering the lifetime of an object, because nothing is infinite, but never forgetting that the surface is an interaction, interplay region. So this is not an absolute. This has to be defined and designed, always thinking about the environment where the object will be placed. So it's a multidisciplinary approach, making use of chemistry, material science, and industrial processes to engineer chemistry and microstructure of a surface so that we can deliver a targeted properties. And this is what I call surface technology or surface treatment. What is research doing in this field? The research is nowadays focusing on developing new coating systems, giving new surface functionalities, but always looking into more environmentally friendly treatments. As we use a lot of chemical treatments, today we're looking into reduce the footprint and make the processes more environmental friendly. So you remember this picture? I would like to give you an example of what type of functionality we can develop. And because this is the area of smart things, smart watches, smart phones, smart TV, so why not have smart coatings as well? We don't want to be left behind. So this new field of smart coatings is the field where coatings are created capable to take action when needed, to respond to a trigger, to an input, by changing one of their properties. Maybe you have heard about antibacterial coating, drug delivery surfaces, self-cleaning material, thermochromic glasses, biomimetic materials, de-icing surfaces, self-healing, osteointegrative, anti-sticking, and more. You can come up with your own smart functionalities. So let's look into a couple of examples to understand it better. What does it mean, self-healing material? Self-healing material is a material that, when damaged, can get healed by itself without our interaction. So self-healing coating are those coatings that get scratched or damaged once in use, but they can reclose the defect, as you see in the picture here, by making flow of material inside this cut. And one of the applications is for corrosion protection, as in this picture here, because if I have a scratch, inside the scratch, corrosion will start to happen. But if the scratch gets self-healed, then you do still see maybe the scratch on the surface, but no corrosion can happen because we are closing again this interface. Another nice application is for optical purposes. Very often you can go home and look at your glasses, the nice wine glasses. Isn't it that after using them a lot, they get little tarnished, little matte? This is due to many micro scratches on the surface. And if we do have a self-healing coating on it, just by exposing it to some heat, then the scratches get repaired and you regain the initial gloss and the initial transparency on the material. Another example of smart coating are Thermo and Photochromic coatings. We do apply, for example, in this case, to glass, a coating that is smart in the sense that can react to the temperature or to the light by changing color. For example, smart glasses can be transparent when we have room temperature, and when it becomes too hot, they become a little bit darker and filter the ER sunlight so that the room inside doesn't heat it up too much. Or maybe some of you have photochromic glasses. If exposed to the sunlight, the lens color changes from transparent to sunglasses. And this can be a reversible process. As soon as the light goes back, the color goes back, or it can be permanent. And then we deliver and we produce smart sensor. Because, for example, in this case, we can have stickers that detect when the temperature changes and then doesn't go back again. And this is used, for example, in the cold chain of food to tell you that the frozen food has never been defrozen before. And you can check those sticks to verify it. So if I want to give you one example that comes from my own research, then I can talk about dispersion coating produced by electrodeposition. And these are the results that come from the research run here at Jönköping. Dispersion coating are those coatings that combine two materials, a matrix, metallic matrix with a dispersed phase. And in this project, we produce antibacterial photoactive metal layers. We created particles that are responsive to indoor lights, like lamps, and we combined them with tin nickel alloys by electrodeposition, and I will not enter here, but we will co-deposit them together, so we have the metal with particle inside it, as you can see in this cross-section. And then we look at the coating microstructure, depending on different material and comparing back to the reference material. We do measure the photocatalytic activity. Are they responsive to the light for real? And then we use this input to create a feedback loop and change the process parameter once more until we reach the optimized property we want to have and create real object and send them to field exposure to check if they work for real. So in this project, we produce a reference coating and the project coating into a panel and into some door handles, and we left them there for 4 weeks in different places in a public hospital, and we measured the number of live bacteria left on the surface after those 4 weeks. And the result is that the coating with this smart functionality was able to reduce by 63% the number of bacteria on the surface. And imagine the impact that this can have, impact public places like schools, stations, or hospitals. So I hope today you have seen how special the surface is, is a place where spontaneous interaction happen, both positive and negative, and therefore it's important to control them by our advantage. No matter if you are looking for an armor or a makeup, surface technology is your answer, and this makes it a field of applied research with impact in any application. It's a very diversified, multidisciplinary, and complex field, and if well-engineered, tailoring chemistry and properties and process will produce many smart coatings that will improve your own daily life. So, have you heard the quote, "It takes a village to raise a child"? I personally think that it takes a village also to raise a scholar. And therefore, I would like to conclude by acknowledging my village, because I do owe a big thank you to my mentors, to my PhD students and postdocs that worked under my supervision, and collaborate in producing the results that are being shown today as well. The colleagues at the department here in Jönköping University, and Last but not least, the support of my family and friends. And I do apologize that a couple of pictures are not appearing in the presentation. Thank you very much.
Thank you so much.
Thank
that was
you.
so good. And now I wonder why I ever signed up for the economics department. That was a great presentation.
Thank you very much.
And congratulations.
Thank you. Thank you all.